Hello and welcome back to my new Catia V5 tutorial. Today we'll learn about the various ways of replicating features on a part. More precisely, we'll learn about patterns and my personal favorite, the axis-to-axis transformation. But most importantly, we'll learn about the strengths and limitations of each one and how to use them properly in order to create stable parametric models with focus on putting in the least amount of effort. After all, progress is made by lazy people inventing easier ways to do stuff. So let's not waste any time and begin. We will start with the pattern, which is the simplest one. The pattern is accessible through this button here. For the sake of this discussion, we'll group the rectangular and circular pattern together since they function nearly identical. And we'll talk about the user pattern later. So rectangular pattern. Let me start out by saying that these commands are accessible both through the part design and the generative shape design workbenches. And in both they work the same, but when using it on solids, it will not work with Boolean operation or any of the dress-up features. So to use the pattern, it's pretty straightforward. You just have a sketch and create a pocket in one of the parts, something like that. Then you can choose to pattern it. You select the reference direction, and afterwards you select what you want to pattern. In our case is this pocket here. Reverse the sides and voila, it looks like this. Here you have various ways of constraining the length and spacing. The most interesting one is instances and unequal spacing, because this will allow you to create multiple instances and edit the spacing in between each one of them. This actually I did not know before starting to make this video, and I found it quite interesting. In the same command you can choose to add multiple directions, so you can have this direction as the first one, the second direction is x-axis. You need to choose what you want to pattern, and you can add basically this pocket you can create a grid of this pocket. Now if you click on more settings here, you can then choose to offset this grid in any directions that you want, and the most interesting thing I found was that you can actually stagger them like this, and this creates a beautiful mesh-like surface. Now this is not just useful for creating this mesh, this kind of mesh surface. You can also use it to actually position some screw holes, and here the instance and unequal spacing comes really handy. Okay, so let's remove this. Like I said, you can also use it with surfaces. You can go to generative shape design. You can actually have surface going like this, Y, and then you can use a pattern like that. And afterwards you can go back to part design and cut your part with this mesh. This gives you the opportunity to work in both surfaces and solids. And you have an intermediate step where you can actually do something with the surface before. For the circular pattern, there isn't much to say. It functions nearly identical as the rectangular pattern. Instead of a direction, you choose the rotational axis, and instead of a second direction, you have the number of crowns, I guess they're called. And of course, instead of distance between instances, you have degrees. Now, to note that here there's a particularly interesting one. It's called a complete crown, where it evenly spaces the number of instances around the 360-degree circle. So just to give you an example of how this would work, you will have a pocket inside, like that. You will select the reference axis, let's say in this case it's the x-axis. You do not want to pattern the complete solid, you want to pattern the pocket. And maybe this is not the right one, this is actually the y-axis. And here you select the angular spacing between them. Of course you can select multiple crowns, and of course you have the option to offset and stagger them. Now you will notice that, let's turn this whole thing off. We'll keep one crown, something like this. You will notice one limitation here. For example, let's say this pocket here, I don't want it to go all the way like this. Let's say I want it from this exact point, I want it to have kind of like a blind hole. When I pattern this blind hole, you can see the first one is a little bit shallower, and the last one goes all the way through the part. Why is this? Well, that's simple, because the pattern actually takes the first hole from this point onwards, and it just keeps the same, in this case, y coordinate for the start of the hole. So that means here, if my surface moves, then my hole will not be a blind hole, it will be a through hole. Or in other cases, it won't be a hole at all. So how do we get around this? That's very easy to do. First we need to delete this. We can delete the pocket as well, because we don't need it. And we go back to the geometrical set and start in the generative shape design bench. Here we will create an extrude of this circle. We'll make sure we keep it like this. That is perfect. Now we need to have this surface, the one that we use to generate this. We can either extract it, or if you already have it in the construction, you can use that. You can offset this to the desired amount, let's say 2 millimeters of this. Seems pretty much okay. Now you can choose the pattern here, the circular pattern, and pattern this particular extrusion. The direction is Y, I guess. I was a bit wrong here. We actually need to extend this further away. Now you need to trim this with this. You need to make sure you keep only what's inside. We keep all the sub-elements. We can go ahead and hide this part. We need to do the exact same thing for the first one, because for some reason the first one is not included in the pattern surfaces. And now we are left with these cylinders here. And actually we can use these cylinders to cut into the part. We go back to the main part. We go to part design. And then we split this like this. The first one, and then the rest of them. Now if you hide your surfaces, you can see that we have the same depth on all the holes, and it's going to go all around the surface. And furthermore, you can actually adjust this, and it should in theory work. Let's see. Let's test it out. Cool, right? Now you would think that actually this is what user pattern is used for, but it has nothing to do with this. It's an entirely different use case. Now to talk a little bit about the user pattern and what it is. This pattern type is not intuitive at all. It is basically a series of translate point-to-point commands bundled up into a single element. So you have this translate point-to-point option, where you select the feature you want, select the start point, the end point, and it just basically copy-paste it into that position with keeping the same orientation. The user pattern would just basically do this for each of your input points. The strange thing about this command is that it doesn't take in a series of points as you would expect, but rather a multiple point element, which is honestly insane to me. It makes absolutely zero sense why Dassault would do this. Anyway, we'll see how to get that multiple element, and the best use case for this that I could think of would be a situation where you have an uneven surface and you want to create some resting interfaces for a different part that fits into this, and you want it to have the same orientation so that it would be easily assembled. So let's try to create our multiple point element. To do that, I think the easiest way is to make a sketch and position the points somewhere on this sketch. You can have them like this, something like that, and afterwards you constrain each one of them. Right, you don't have to constrain them, it's just good practice to do so. Now, you take these spots and then you project them onto the surface. But you actually don't select that, you select the whole sketch. You choose this as a support, and it should be along the direction, like this, and make sure to untick nearest solution to have all the points here and keep all the sub-elements. There you go. Now this project here is now a multiple point element. See, it's only one element in the tree, but it's actually 6 points in the 3D. This is called a multiple point element. Now what you do is select the user pattern, select the object you want to pattern. For points, you select the multiple point element, and the anchor point, you select a point which you would have to create somewhere on your initial geometry. Click OK, and then there you have it. Now we can just go do that to the rest of the fillet like this. Or you can just select each one of the radii. I couldn't think of a better way to use this. This is what actually comes to mind when figuring out how to use this feature. But let me know in the comment section if you have any better uses for this. And now for the ultimate productivity tool, my personal favorite and a tool that really adapts to every need, the axis-to-axis transformation, which is this one over here. Let's say, for instance, I want to take the depression I did in the previous example and pattern it across this surface like this, but I don't want it to have the same orientation. I want it to be normal to the surface in each point, and I also don't want it to have like a flat surface. I want the surface to match this base surface over here, for example spot welding. I have actually used this technique in a previous video to design this flange over here. But back to our part, how would I go about doing that in a professional manner without working too much? Well, the first thing I do is try to create the first element, the one I'm going to pattern. And then I'm going to create the first instance of the pattern. And how do we do that? First, I'm going to create a plane. I'm going to put a plane on this tangent to this in this point. I'm going to create a circle on this plane with 15 millimeters radius. Yeah, let's go with 18. Okay, now I'm going to create a sweep. Looks about right. 20 millimeters with 5 down. Yeah, good. Then I'm going to create an offset of this. 3 millimeters up should be fine. And then I'm going to fillet these together like this. 5 mil, that's fine. This is my first element. I'm gonna need a line here that is tangent to this one, because I have a variable curve. So I'm gonna create a line. It's going to be tangent to curve, and it's going to be to this curve in this spot and on this support. Now I can create my axis system. I don't really need to do this since I don't care about the orientation since it's a circle, but if I would care, I would really need to create this line here. So now the origin is this point, the z-axis is to this plane, and the, let's say, x-axis is to this line that I drew. Now for the second part, I will need to create a new geoset, which I'm going to call pattern. And in this set I will create the first point. But before I do that, I'm going to do something a little bit advanced, but it's totally worth it because it helps a lot. So I need to create two parameters. One is going to be of type length, and the second one is going to be integer. This will keep count of my patterns. So this one, just call it, I don't know, count, whatever, and you need to copy it inside the pattern here. This one will be the pitch, and you can say it's 45 mil to start with. This we could change it to 1. Okay, first point, I'm going to put it on this curve. It's going to be based off this point, and we will put a formula here which will be the pitch times this integer, which is the count. It's going to be 45 for the first one. Now we need to create a plane tangent in this point, and then actually we need to reproduce this line as well. I usually copy paste to save some time and just change the inputs to what I need. I find that it's a lot faster for me. You don't have to do the same. Now we need to create the axis system. I make sure I use these elements, only the elements inside this pattern, and click OK. Next I need to do the axis-to-axis transformation, but I'm not going to transform this fillet. I'm actually going to take the sweep. and I'm going to select this as the origin and this as the target, and click OK. I'm going to reveal this and do this fillet between them as well. Very nice. Now all I need to do is copy this multiple times. I hit Ctrl C and I copy it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Next thing is to just go inside each one and change the count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Hit update, and this just goes along this curve very, very nicely. You can change the pitch now, go with 50 mil, update, and it will automatically update. Okay, now what's left to do is to go to view tree expansion, collapse all, because I don't want to see every one of them. Go to this geoset and do a trim. Now I do need to select each one of them since this is not a multiple element. Probably could have joined them first. Nice, and now I'm going to fillet these, make it purple, and look at it. This is just a fully parametric pattern that you can do by yourself, and it's really adaptable to any situation that you would think of. So let me know in the comment section what your preferred method of pattern is, and thank you for watching. If you enjoyed this video, don't forget to leave a like and subscribe to my channel, and as always, see you next time.